everybody. I'm Madicken Munk. I'm a postdoc at the University of Illinois at Urbana-Champaign. I work in the data exploration lab, and we're really interested in making data accessible through visualization in the lab there. So I'm going to be talking today a little bit about a tool, not necessarily an analysis like most of the talks so far, and this tool is called YT. YT is primarily for the data analysis and visualization of multidimensional, generally volumetric data. So far, YT has been used primarily for astrophysics simulations, you know, this is like pretty far away from geospatial applications, but we're trying to now make YT accessible to multiple different types of scientific domains, including to geospatial applications. One thing that's really cool about YT is that it tries to separate the data ingestion from the data visualization. And so on the left here, I have several different types of simulation codes that YT is able to read in. Each of these simulation codes is a very different output type, different fields on disk, and each one of them can be very difficult to read in and requires a lot of specific domain knowledge. And so YT has custom front ends built to read in each of these different types of data types, and then it reads it into the YT field system, and then you can create beautiful visualizations. So if you have two very different types of simulation output, you could create a very similar visualization with the way YT is structured. So I mentioned that generally YT is supported for volumetric data. We can do lots of different types of volumetric data visualization. We have support for different types of mesh, so structured and semi-structured, unstructured mesh data, and also variable mesh size. So if you have a mesh that varies over a lot of different orders of magnitude, YT has support for that. Also, we can create many different types of visualizations. We can slice along a particular axis in the domain. We can collapse a domain and make a projection plot. We can do volume rendering and interactive volume visualization and exploration. Also, YT has a bunch of analysis features, so you can create a derived field made from two fields on disk. So you might have a velocity field and a density field, and you could combine them to make another field. We can also do clump finding. So given some parameter, you can find all the clumps on disk, and you can filter your data based on those clumps, whatever your parameter searching is. And we can make profile plots and histograms also with that data. Other features that are maybe relevant to people here is that we have parallelization and interactive data visualization. Specifically, that's mostly command line based right now, but we're trying to broaden that a little bit more as well. So this is obviously a geospatial conference. I want to talk a little bit about the new features we've been putting in YT to be useful to geospatial data. The first thing is we made a CF compliant front end. So I mentioned on the first slide all these different front ends that can read in different types of data. The CF compliant front end was done with a collaboration with the PyArt development team. And so we can read in all the CF compliant netcdf4 files. And so this is an example using that front end of the reflectivity and velocity field of radar data. So we can read radar and LiDAR data now. We also can do map projections. So this is with support from CARTO, and this is the global air density on August 22nd, 2018. The data is from NASA. And also we're trying to build more accessible interactivity. So specifically custom Jupyter widgets. So you can browse your data in the web browser. And also we're trying to make it so you can do it based on a server. You can you know, load all your data into your web browser and do it from a local machine. And so you might have a really large data set on a server and you can still browse it far away. And also Glue, which is more of a GUI-based visualization tool. We are also trying to broaden YT, I mentioned, in different domains. So we're targeting many different domains. The first one is oceanography and hydrology. This is actually a plot read in with YT of the global, the predicted surface temperature of water off of the Massachusetts coast. So you can kind of see Massachusetts outlined there. Also whole earth seismography and tomography. This is an image of the Toku earthquake, the waves that were propagated through the earth. Meteorology, Also, not just observational weather, but simulation, weather simulation data. So this is an example of the genesis of a tornado. And lastly, climate science. A couple other things that we're doing is trying to create non-spatial indexing. So right now, YT assumes that you're reading things in spatial, but some of these domains, we have lat long and like pressure rather than altitude. And so YT is going to be able to read in this multidimensional data that is not assumed to be spatial to start with. And also non-local analysis. I mentioned like this plum finding that's like based on the data that's like locally available near a data point. We also want to do like path finding and path propagation. So you might have a path through a system and you then can like integrate all the points over that. So if you think this would be interesting to you and your work, we would love to work with you. I mentioned a lot of like physical sciences, but we're also very interested in social sciences. So if you really want to, if you think this would be helpful, we would love to collaborate with you and come back. Thank you.